So this question says the structures of complexes CuNH3 whole 4 ClO4 2 and CuNH3 whole 4 ClO4. So these are the two complexes which are given, and we are asked to write the structures. I mean, what should be the geometry of these two complexes? The options are A, square planar and tetrahedral, B is octahedral and square pyramidal, C is octahedral and trigonal bipyramidal TBP, and D is tetrahedral and square planar. So out of these four options, what should be the geometry of this complex? Now we have written these two structures, and now we apply valence bond theory to solve this problem. Okay, first of all, let's see this structure. So let's say this is structure 1 and this is structure 2. Okay, now in structure 1, what is the oxidation state of copper? So we have X for copper. Amine has a 0 charge, and then ClO4 has -1 charge, and 2 ClO4 are there. So we have -2, and the charge on the entire charge on the complex is 0. So X comes out to be +2 for structure 1. So structure 1 has copper in the +2 oxidized state. Now we know that neutral copper has a valence electronic configuration of 3d10-4s1. Now, as we discuss copper in the +2 oxidation state, I would like you to know that why this particular complex, or any particular complex with 4 coordinated ligands and copper in the +2 oxidation state, will show square planar geometry. And also in square planar geometry, if there are two possibilities of hybridization with dsp2 inner orbital complex and sp2d outer orbital complex, why this particular complex prefers sp2d hybridization? So we have a copper complex which is coordinated to 4 ligands, and there are two possibilities of geometry with 4 ligands. What are the two possibilities? Either it could be tetrahedral geometry or it could be with a square planar geometry, okay, with 4 coordinated ligands. Now from experimental data, this complex was identified to be square planar in geometry. So initially, what is obvious, all the 9 electrons in the 3D orbitals arranged like this, okay, and then we are left with how many ligand electrons? 4 into 2, 8 electrons from the ligand. So it was very easy to conclude that we can very well accommodate these electrons, the ligand electrons, in the 4s and 4p orbitals like this, okay, and very easily we can get what kind of hybridization? sp3 hybridization. But actually it was seen from the experimental studies related to X-ray and ESR studies that suggested actually that the compound is not tetrahedral but a square planar complex. Okay, now when scientists identified, okay, this complex is square planar, then that means this filling of electrons and the conclusion regarding the hybridization is absolutely wrong. So this way only tetrahedral geometry can exist, okay. Now what to do when the geometry is identified as square planar from experimental studies? Now we have to accommodate and think in that way. So for square planar geometry, again there are two possibilities of hybridization, okay. So either the hybridization could be an inner orbital complex pertaining to dsp2 hybridization, and it could be an outer orbital complex sp2d like this. So these are the two possibilities for hybridization in a square planar complex. Now out of these two, what should be the real hybridization? Now, first DsP2 was attempted. So how it was attempted? So it was suggested that the D9 electron, the last electron, single unpaired electron, migrated to 4p orbital. Okay, when it migrated to 4p orbital, so this 3d orbital became vacant. Okay, so it became vacant and the situation was like this. So here it was, so this orbital, 3d orbital became vacant, and then the 8 electrons of the amine ligand can be accommodated in the dsp2 hybrid orbitals like this. Okay, so this was the conclusion given for the inner orbital complex with dsp2 hybridization. But it was also found experimentally that copper, this particular complex with +2 oxidation state of copper, is highly stable, okay, and not very reactive. It was quite stable, and that stability couldn't be justified by this kind of arrangement, by the dsp2 hybridization. Why it couldn't be justified? Because this electron, when it migrates from 3d to 4p, that means it is going towards the higher energy. Okay, and this single electron always will have a tendency to escape. Okay, so it will be lost. That means this particular complex should be highly reactive, but actually this complex was found to be very stable. So the justification of stability couldn't be achieved through this kind of electronic arrangement, which gives us the dsp2 hybridization. And then ultimately we are left with what option? Only the outer orbital complex sp2d option. Now let us see how can we arrange the electrons in sp2d hybridization. So in sp2d electronic arrangement, the 3d electrons, all the 9 electrons of 3d are left untouched. So this is undisturbed. It stays as it is. The d9 electrons, all the d9 electrons stay in the 3d orbitals. Okay. Then what happens? What about the 8 electrons contributed from amine? So they are arranged like this. So 2 in 4s, then, okay, and then one orbital of the 4p is left vacant, and this electron pair migrates to 4d orbital. So it then becomes this hybridization. Okay, S, 2 orbitals of 4p, sp2, and 1 orbital of 4d, d, sp2d. And this perfectly satisfies the stability of this complex, because this migration is not of a single electron, and it is not going from a very low energy state to a very high energy state. So this migration is justified, hybridization is justified, and ultimately it leads to the square planar geometry which is observed from the experimental studies. So I hope this explanation is clear. So you can see all along all kinds of hybridizations were tried to justify the two geometries which are possible for 4 coordinated complexes in copper +2 oxidation state. So in 4 coordinated complexes, there are 2 possibilities, tetrahedral or square planar. Tetrahedral, it could easily give rise to tetrahedral logically, because all the 8 electrons of the ligand can be accommodated in 4s and 4p. But this was not according to the logic, but according to the experimental studies which said that this particular complex is not tetrahedral but square planar. Then scientists were left with 2 options. Square planar geometry gives rise to hybridization of dsp2 inner orbital complex or sp2d outer orbital complex. So initially dsp2 was tried, which was found to be unstable. So this theory was also discarded. And then the scientists were left with only one option, that is the outer orbital complex, which arises from the sp2d hybridization. And to justify this, the pair of 4p electrons, they migrated from 4p to 4d, giving rise to sp2d hybridization. And this kind of migration was justified and it led to the stable complex. So all of these factors led to the ultimate conclusion that the hybridization is sp2d for this particular copper plus 2 complex. So I hope this explanation is quite clear to you. Now let us see what happens to the second complex. So x plus 0 minus 1 is equal to 0. Minus 1 for ClO4 ion. Okay. So x becomes plus 1. Okay. So the oxidation state of copper in this second complex is plus 1. So what should be the valence electronic configuration? So there is a little mistake here. The copper here is plus 2 and I have written 1 oxidized. So this is copper in the plus 2 oxidation state, okay, in the first complex. Okay, now in the second complex, it is plus 1 oxidized state. So what should be the electronic configuration? It should be only 3d10, 4s0, okay. So we have to fill these d10 electrons and rest of the things are same. That is, the contribution by amine ligands is 8 electrons from amine, which has to be accommodated. Now let us write the electronic configuration for this complex. So we accommodate first of all the 3d electrons of copper. Okay, so all the orbitals are filled because we have 10 d10 electrons. So there is no question of unpaired electrons here. And then 8 electrons should automatically go into 4s and 4p orbitals. So 2, 4, 6 and 8. So clearly this is sp3 hybridization. sp3 hybridization, and the corresponding geometry is tetrahedral. That means what should be the correct option in this question? What should be the answer? So the answer will be, so for the first complex where we have ClO4 twice, it is square planar, right? It is square planar. And for the second complex, the geometry is tetrahedral. So it is tetrahedral for the second complex. Okay, so option A is the correct option. So what is the difference between these two? Only difference between the two complexes is, in the first complex, copper is in the plus 2 oxidation state having D9 configuration where we have an unpaired electron. And in the second complex, copper is plus 1 oxidized. So we have D10 configuration where there is no unpaired electron, and easily the 8 electrons of amine are accommodated in the 4s and 4p orbital, giving rise to sp3 hybridization and tetrahedral geometry. So hope this explanation is clear and hope it helps. Thank you.